I'm Anil Kumar, and in this video we will understand combination of two functions. We are given f of x equals to x minus 1 and g of x equals to minus x squared plus 1. We need to sketch h of x, which is combination of f of x and g of x. Right? So how are you going to do such a question? Now you can always combine two functions on common domain. Fortunately for us, both these functions have domain as all real numbers, right? So let's write down their common domains. So common domain is x belongs to real numbers. These are critical things to understand before you begin to start your solution of the question, right? So they could only be combined in common domain since both have all real numbers as domains, so they can be combined on all real numbers. Now, when we have to add them, what do? We basically superimpose the values of y, right? So that is what we go. So superposition rules will follow. Rules will be applied. What do that mean? It really means that for any given value of x, f of x and g of x, y values will be combined. Okay, that is what it means, right? So to begin with, what we will do is we'll make table of values. We could also combine these equations, form an equation. So we'll have both the approaches. So let me first make table of values so that we'll just plot these two and then get the function, combination of function, right? And we'll also do the algebraic method, right? So for making table of values, let me take some x values. Good values to take for these two functions will be minus 2, minus 1, 0, 1 and 2, right? Now f of x is x minus 1. So we just take away 1 from these values to get the value of f of x. Minus 2 minus 1 will be minus 3. This will be minus 2 minus 1, 0 and 1. So we get f of x values. Let me use another ring for g of x. So for g of x, we will have minus x squared plus 1. See, minus is outside. So you are squaring minus 2, you will get positive 4. But then you should do minus 4, right? Plus 1 will give you minus 3, correct? Minus 1 square means 0. You are calculating from here. This is your function, okay? 0, when I substitute here, I get 1. If I substitute 1 here, then I get minus 1 plus 1 as 0. If I substitute 2 here, 2 squares is 4. Minus 4 plus 1 gives me minus 3. Got it? And we'll use a different ink for the combination of the two functions, which is h of x for us, okay? H of x. So h of x is addition of these two, so let's add them up. So you get minus 6 here. When you add them, you get minus 2, 0, 0 and minus 2. That is what you get. So if I plot these values, I get both the functions on the graph. How is this graph going to look like? What I will do here is I'll also find h of x by combination of these two functions. So let me write h of x as f of x, which is x minus 1, right, plus g of x, which is minus x squared plus 1, correct? So basically what I did at this stage was I added g of x, right, with f of x, correct? That is what I did, right? So when I added them up, what I got was h of x. This is what I'm trying to find out, correct? So let me just expand this expression and combine the like terms. So if I combine the like terms, what do I get? I get minus x squared. I'm writing them in particular order. It is good to write with decreasing orders of exponents, right? So that's the highest order. Then x, right, plus x. Minus 1 plus 1 gives me, when I add them up, minus 1 plus 1 gives me 0. So I get 0 here. So no need. Anyway, let me write 0. Anyway, so I get a function which is minus x squared plus x, which I could, common factor is x. So if I take common factor, my x, I get x minus 1, correct? So it's a parabola with two x-intercepts, the one at 0, that is what it is, right? The other one is at plus 1, correct? So that is a quadratic function which is h of x, combination of these two, right? So you could do, you can write a simplified form of h of x, which is combination. Then you know the nature of the graph. It helps you to connect the points. That's the whole idea, right? So let me first sketch the function f of x, right? So okay, so I'll sketch this in some light color. Let's say this one is the color for me. So at minus 2, I have minus 3. So this is 1 point, minus 2, minus 3. Minus 1, minus 2. Sorry, minus 1, minus 2. Then 0, minus 1. 0, minus 1, 1, 2. So that's a straight line, correct? So I can connect this line and graph f of x, correct? So this is f of x for us, correct? Now let me use blue color for g of x, which is a parabola, right? Minus x squared plus 1. So it is at minus 2, it is minus 3. So this point is common, right? And then we have 0, 0, plus 1, and then again a 0. And from the symmetry, you know it is minus 3, correct? So if I join these points, I do get a parabola, smooth curve, correct? So it's kind of like this. Okay, so that's the parabola which represents the function g of x. Let me write g of x here. Correct. So we get these two functions. When we have to add, this is actually the third method also which can be applied. You graph it and then you add corresponding values, right? So let's begin with the center itself. From 0 we'll go right and then come back, right? Okay, at x equals to 0, for f of x it is minus 1 and for g of x it is plus 1. When you add them, you get 0. Do you see that? And this matches with our 0, correct? If I move to position 1, then both are 0, so adding them gives me 0, right? If I move to position 2, in that case, one value for us is minus 3, the other one is plus 1, so addition is here. Is it okay? So we'll consider these values for the time being. And as I move to minus 1, at this I have 0 plus minus 2, so this is the common point. At minus 2, the value is minus 3 for both, so it is minus 3, which will be kind of minus 6. So let me draw it here. Okay, I hope you can see that. I'll push the page a bit. Right. Okay, that's fine. So we do get a parabola as expected with 2x intercepts, right? We have not really calculated the center value, but as a special case, what you can do is you can substitute. Let me write down here. So what you can do is you can find the value at the center, which is 0.5. If you substitute 0.5, use your calculator, and you can calculate this value, correct? So basically, we'll substitute in this equation. So we get minus 0.5 times 0.5 minus 1, right? So 0.25. 5 times 5 is 25. So minus, this is minus and minus, that becomes minus 0.5 times minus 0.5, which will give you plus 0.25, correct? So slightly above, so that is your maximum value, right, in the center of these two x-intercepts. So with that, you can actually plot your graph, right? So you can plot your graph kind of like this, right? Kind of like, you see that? So that is, that is h of x for you. So combining the y values for the same x value helps you to get the value of combination of functions, right? So in this particular video, what we learned here is, given any two functions, find common domain. They could be added or subtracted, or the combination of operations for two functions can be done in common domain only. So on that common domain, for each value of x, we have to combine the values of y. to get a result which is combination as the cases. You could do this by making a table of values as we did. That is method number one. The second method is you could do it algebraically. You can combine, since the functions are given to us, just add them up, rearrange, right? So you know that is representation of h of x. And then you can sketch, right? Here what I did was I used table of values to make both these functions, and also applied my techniques to sketch parabola using my equation and made a perfect parabola representing h of x, which is combination of linear and quadratic function as given here. I hope this example helps you to figure out how to do combination of functions when addition operation is involved. In the following video, we will see the subtraction, multiplication and division operations one by one. I hope that helps. Thank you and all the best.